I'm going to discuss a trick for quickly factoring cyclic polynomials. Both examples here are homogeneous. Here is the trick. Let p of x be a polynomial with a root a, meaning p of a equals 0. Then x minus a is a factor of the polynomial. This result is related to zero-factor theorem. We are going to use this to factor the polynomials. The first one, let p of x equals x minus y cubed plus y minus z cubed plus z minus x cubed. Here, we consider the expression as a polynomial of just one variable x, and y and z are parameters. P of y, we plug in y here, equals y minus y cubed plus y minus z cubed plus z minus x is replaced by y cubed. Y minus y is 0, and y minus z cubed and z minus y cubed cancel out. So P of y equals 0. Then, by the trick, we know x minus y is a factor of the polynomial. Because the polynomial is cyclic, we can similarly conclude that y minus z and z minus x are also factors of the polynomial. Therefore, x minus y cubed plus y minus z cubed plus z minus x cubed equals x minus y times y minus z times z minus x, 3 factors times a constant. Notice that both sides are cubic polynomials, so the difference is just a constant. In order to determine the constant c, we try x equals 1, y equals 2, and z equals 3. Plug them in. We have 1 minus 2 cubed plus 2 minus 3 cubed plus 3 minus 1 cubed equals the constant c times 1 minus 2 times 2 minus 3 times 3 minus 1. So for c, we got c equals 3. You can try other values for x and y and z. You will also get exactly the same value for c equals 3. Finally, the factoring of the polynomial is 3 times x minus y times y minus z times z minus x. The second one is a polynomial of the fifth order, slightly trickier. Similar to the previous example, we know it contains factors x minus y, y minus z, and z minus x. But the left-hand side is a fifth order, so it contains another quadratic factor. I call it q of x, y, and z. It should be homogeneous as well. As a homogeneous polynomial, there are a total of 6 second-order terms, different combinations for x, y, and z. They are x squared, y squared, z squared, xy, yz, and zx. We need to determine their coefficients. However, we know the polynomial must be cyclic, so the coefficients for x squared, y squared, and z squared should be the same, and the ones for x, y, yz, and zx should be the same as well. Now, we have only 2 constants to determine a and b, and we need 2 equations for that. Plug in 2 sets of numbers for x, y, and z, we will have 2 equations in a and b. For example, we can plug in x, y, and z equals -1, 0, and 1 respectively, or 0, 1, and 2 respectively. Clean up the equations, we have this simple system of equations in A and B. The solution is A equals 5, B is -5. And finally, we have the factoring of this fifth-order polynomial as 5 times x squared plus y squared plus z squared minus xy minus yz minus zx times the rest of the three factors. Thank you for watching.